Hi, in today's session, we'll understand why we use the unit circle in trigonometry. So, I guess you guys are gone through all of the formulas in trigonometry and you saw you making use of the unit circle more often whenever you're talking about the sine theta function, the cos and the tan and everything. But all of those formulas are coming out of the major thing, which is the right angle triangle. Depending on the position of angle, input angle, which is your theta, you're going to decide which is opposite side and which one is adjacent side. And the longest side is obviously the hypotenuse, and you know the formulas for sine and cos and the tan. So this is the history that we should remember before we get into the unit circle. So the thing is, the right angle triangle that we see serves the purpose of designing the trigonometric functions. Remember, a function is a set of a formula that serves this ideology of taking certain input and performing action, taking certain input and the action, and this action gives us a relevant output. So that's for a regular function. And here in trigonometry, the trigonometric functions, which are sine, cosine, tangent, everything is doing certain work. Like sine theta gives us the relation between how the opposite side is related to the hypotenuse, which is literally the height of this triangle, right? So can I say the sine theta representing the height of this the triangle with respect to the hypotenuse? Why I'm specifically saying respect to the hypotenuse, because what if the hypotenuse is too slant like this? Then the triangle is smaller. The triangle is having a smaller height or the length. If it's too high like this, the height of the triangle is, it's getting larger in this case. So the opposite side is depending on the hypotenuse. Depending on the hypotenuse, we can able to figure out the length of the triangle. Just like that, we have specific functions designed. Here, the function of trigonometry takes the input as an angle. With respect to this given angle, what is the respective output? Sine theta defines the output of opposite length or the length of a triangle, and cos theta defines the base length or the width of the triangle, and tan theta, it's about the tangent function, which is literally the slope of the point, which is extremely at that opposite lines at the top. So this is certain things that these functions do and all. But now, getting to the real point, which is why unit circle? Why not anything else? The thing is simple. Oh God, this thing. Let me just take you to this unit circle. Unit circle, unit means one. That means the radius is one. It is quite simple. You see, whenever you have a denominator as 1, you can literally say whatever that I have on the left hand side equals to whatever I have on the right hand side. So sine theta is opposite side. You're literally saying stop the drama of you relating to the hypotenuse. Just focus on sine theta gives you the opposite side of the triangle, which is extremely directly proportional. So in this case, you can literally study the relation between the height and the width of the triangle. Now, let me switch my words. Instead of saying the triangle, I'm going to say the coordinate points of any point over the circumference. The reality of using this sine theta, cos theta, all these trigonometric function is to figure out the length and the width of this, or the coordinates, x and y coordinates. Treat it this way. X coordinate, this gives you the width. The y coordinate gives you the height. This exact point is placed at. That's it. That's the story of doing these functions of trigonometry, which is sine, cos, tan, and everything. Now, this relation of being the radius of 1 gives you the direct access to the original values of what is this trigonometric function is doing. But now the case is little different. What if the radius is not 1 but more than any value? Let's say r is greater than 1. You can't take the radius less than 0. That's why r must be greater than 0. So if it's greater than 1, then all you need to do is just simply multiply, because you see, Can I take this r value, which is your hypotenuse, in the place of the hypotenuse right here? That's why sine theta becomes opposite to, instead of hypotenuse, I'm going to write the radius because both are same in this case. Now, your opposite side length gonna be whatever the radius you have multiplied to the sine of theta function, and your theta defines your input angle that you would like to place. Obviously, for every input angle, let's say this input angle gives you certain xy coordinate, and this guy, let me take a different value, a different color. So this angle gives you certain x and y coordinate. X and y coordinate, basically x defines the width and y defines the height, and this resonates with the right angle triangle. That's the major use of, we analyze the right angle triangle to make use of the points, to recognize the points. Okay, I hope that makes sense, right? You see, the radius multiplied with the sine of theta function gives you the length of the triangle, which is your opposite side. That's it. That's the case. When we make use of the radius as one, it's so easy for us to understand the relation between opposite side or whatever the defined function with a trigonometric function. Sine gives you the opposite side, great. Cos gives you the adjacent side, great. So you have no middleman right here, like the radius is obviously 1, so cos theta gives you adjacent side or the base length or x-axis value. Just like that. Now, the final act, what is the tan theta gonna give you? Tan theta is like sine to the cos, right? Sine gives you the y coordinate, cos gives you the x coordinate, y because it's length, x because it's base. And now when you take this slope, that's the formula, right? M equals to change in height to the width, that's the slope. And that's exactly what this tangent function do. How much slope the given point has with respect to the position of its replacement. See, this point has certain slope, this point has certain slope, and that can be figured out using the tan theta function. So that's it. That's the ideology behind making use of the unit circle to make our work easier and smoother in the beginning. And later, if you want to substitute the relevant hypotenuse value or the radius value, just make use of this formula. Just multiply with the radius, whatever you have, with the sine theta function. That gives you the exact height and base and the tangent function, whatever you want. But the basic ideology behind this trigonometric function is to figure out the details about the points which has been scattered on the 2D plane. Over the 2D plane, you can literally travel to the entire circle position. You can be at any place. We can still figure out all of the details with respect to the center of where we are standing at and where we would like to figure out the details from. So what do you want? Just you want the base, you want the height, and you want the base length. If you got that thing, you can figure out the slope of this point. Now you literally know everything, every detail that you can possibly think about that given point, and that can be figured out using the trigonometry. Let me just do this thing. The drawing is horrible. Let's say this point. This gives you the height, which is sine theta function. This is radius. You don't need to care about it now. The base, cos theta function, and height, sine theta function. That's why they write simply base is x value. That's why cos theta to sine theta. Now look at this image. That's why this guy is holding this cos theta to sine theta function to represent the base and height values of this point. Remember, it's all about the point. The reference of the right angle triangle within this unit circle, and only making use of the unit circle. Everything is just to make use of the work easier and relatable and easy. That's it. So yeah, that's all about why we make use of unit circle and how it turned out. I guess you got a idea over why we do all these things. So if you are just learning this trigonometry things and all, and you still have more confusions and doubts on any concepts so far, you can check out my beginner level trigonometry class just for 1 hour. I'll be listing out on the description. So once you go through this thing, you're gonna get an idea that how these words specifically do the work, and you can easily master this thing, the base knowledge. So I'm gonna list it on the description, and thank you so much for watching my video. I'll see you soon.